Alright, this is the final assembly that I'm going to be showing you how to model. So in a new assembly file, I'll start by using the existing component icon. Click on that and then click on the tree and locate the first part I want to bring in, which in this case is going to be the master rod. I'll do the same thing, bring in the master rod bearing. Using the manipulate button, I'm going to separate the two of these. Just slide that bearing along its axis. Then using the coincidence constraint tool, I'm going to make the center line of the hole and the bearing coincident. And then using the offset constraint, I'm going to put in an offset of 0. Hit existing component again. And now I'm going to bring in the piston. And do the same thing and bring in the piston pin. Again, I'm just going to separate these using the manipulate button. I want the pin to be coincident with the hole in the piston. And as you can see here, there is a small gap. And I'm just going to go and do another offset constraint. If you look at the drawings, you'll see that it actually is indeed 2.5 millimeters. So I'll just click OK. Now I'm going to bring in the piston pin plug. And I want to do a coincidence constraint as well as a contact. Contact constraint. I'll bring in one more plug. And do the same thing. Now I'm going to bring in the articulated rod using the same process. And then I'm going to insert the bushings. So I'll start with the upper bushing first. And I'm going to constrain that using a coincidence constraint and an offset constraint. In this case, the offset is going to be 2 millimeters. Now I'm going to place the upper bushing, which is the larger one. Again, I'm just going to clear it out of the way using the manipulate button. It just allows me to get better access to the inside cylindrical surfaces. Makes it easier to do the coincidence constraints. And since that bushing is the same width as the hole at that end of the articulated rod, the offset is going to be 0. Now what I want to do is constrain the rod to the piston, or vice versa, depending on how you look at it. I'll do that with a coincidence constraint. Now what I'm going to do is I need this rod to be perpendicular to the bottom plane of the piston. So I'm just going to manipulate it, get it close using the manipulate tool, and then I'm going to do an angular constraint, and I'm going to make these perpendicular. So there our rod is now perpendicular to our piston. Now I'm going to do a coincidence constraint between the lower bushing and the hole on the master rod, and a contact constraint. Now looking at figure 11-95, you can see it doesn't look like this. So what I need to do is I need to put in an angular constraint. And just doing some math tells me that the angle between the two faces I have highlighted is 75 degrees. So in this case, if I do the complementary angle, 105 degrees, I'm able to get the orientation that I need. I just need a few more components to get this portion done. Put the link pin in. I'm going to constrain this using coincidence and contact. The update button, and there we go. Pin is where I want it. Now I'm just going to bring in the piston ring. It's going to be concentric with the piston, so I'll use a coincidence constraint. I'll try and find the center line of the piston here. Yep, that's it. And then I want to do a contact constraint between the top of the ring and the bottom face of the groove in the piston, and also the inside face of the ring and the face in the groove. Click OK and then hit the update button, and there it is, the ring is in place. Now click this button right here, the fast multi instantiation, and that's going to make another ring for me. I'm going to go ahead and constrain it the same way. Now I just need to get 2 more of those. I'm not going to show that, the process is the same. So there's a total of 4 rings per piston. And then that whole assembly of that articulated rod and piston can be repeated another 3 times. And then that whole piston assembly can be repeated onto the master rod. When that's all said and done, you should end up with an assembly like this, with the angles between each rod constrained, according to figure 11-95. And there's the completed radial engine assembly.